Guys, so this lesson, is on the history of the universe. History of universe. And basically, you guys got to know like the life cycle of a star. So this is actually quite easy, the life cycle of a star. So basically, they think that the universe began with a point smaller than an atom. And they think that like all matter in this universe, imagine this galaxy, imagine the Earth and the Milky Way and all the galaxies in the universe. Imagine all of them compressed to a single point smaller than an atom. Because all of this matter was compressed so tiny, it couldn't contain itself and it burst. And then that's where you got the Big Bang. So that's what they think the Big Bang theory is. Like they think that all matter was once smaller than the size of an atom. They've done mathematical calculations. Apparently it's possible. Couldn't be contained. Boom! The universe was created. Big Bang theory. Now the first thing that was created after the universe was compressed into a point, there were two things that happened. There was gravity. Okay, the gravity came. And the gravity was huge, right? So they think at the beginning of time, at the beginning of the universe, there was like hydrogen and like helium, and those are basically all the gases that existed. And that there were these big clouds of gas, and they're called nebulas. Okay, so imagine this big cloud of gas, it's called a nebula. And that because gravity was created at this time in the Big Bang theory, that gravity kind of pushed this hydrogen and helium that made up this nebula together. And the effect of gravity caused what we call a nuclear fusion reaction, where gravity just pushed these elements closer and closer together, so they fused together, right? So basically, like if you can bring two hydrogens close enough together, they become helium. So that's called nuclear fusion, right? And so they think that there's three types of stars you can get. You can get a low mass star, an intermediate mass star, and a high mass star. And they think that a low mass star that's like our sun. Our sun is a low mass star. It's not that hot. You can tell because it's like yellow. A really hot star is a high mass star. They're like violet. They're like burning violet, right? They have more energy. And then they all have like different life cycles. So we're going to talk about our sun. So the sun that we, allows all of us to live on this planet and everything to exist is a low mass star. And it started with having a nebula, right? And then the nebula, so imagine the gravity that's working on this nebula. And basically you got like a nuclear fusion happen. And you got this like core and you get this core, it's made up of helium, right? And helium was created because maybe this nebula just had hydrogen in it. Gravity pushed all the hydrogen together to make this helium, right? So there's two actually opposing forces, right? When nuclear fusion happens, right? Gravity is trying to like push inwards, but nuclear fusion pushes outwards, right? So this is pushing out, gravity's pushing in, right? So as fusion is occurring, right, it's pushing out, gravity's pushing in until like, gravity always kind of wins. And if gravity wins, then all the helium, right, that's in the core may become like oxygen or carbon. The thing is all elements that are on Earth today was created by fusion reactions that happened in stars, right? And so when we talk about stars, we're talking about like ourselves and planets, and all of that was created from like stars, right? Because all matter was created through fusion reactions. Anyways, so when you get these helium atoms like kind of getting closer and closer together, they can make things like oxygen and carbon. And then sometimes, right, you can't fuse anymore. Like it stops at oxygen and carbon. If the nuclear fusion reactions can't occur anymore, then gravity wins. Gravity starts pushing on it, too much pressure, right? And then nuclear fusion loses. So you start to get like this sort of like red, it's called a red giant, and it's in your book, The Life Cycle of the Stars, and you can actually fill this in with your own notes. But when you have a low mass star that begins with like a nebula, you get like nuclear fusion occurring, and then nuclear fusion only occurs up to a certain point. Then you get like what we call a red giant star, which just means that it just becomes like this bigger and bigger and bigger giant massive star, and it's eventually like our sun is going to become a red giant, and eventually it's going to consume the earth, but that's not going to happen for another like 100 billion years, so you don't have to worry about that. You're safe. And then eventually it becomes a white dwarf, and a white dwarf is just the remnants of the fusion reaction. It's just the part of the star, right, that is still shining. I'll tell you guys, like, once you have a nuclear fusion reaction occurs, like once hydrogen becomes close enough to become helium and you start seeing these fusion reactions, that's when the star begins to shine. So shining star is because fusion reactions are occurring. That's what's causing the star to shine. And then that white dwarf is still, like, there's no more fusion after you have the red giant. You get a white dwarf, but it still kind of glows as a remnant of the fusion reaction. And the very last is called a black dwarf, which means that just sort of nothing is shining anymore, and it just sort of, you know, you can't see it anymore. It's like a dead star. And that's a low mass star. In an intermediate mass star, you start with a nebula. You have nuclear fusion, but you have more nuclear fusion. I just want you guys to know that nuclear fusion can only occur till you reach like iron, and then you can't fuse anymore past iron. And then if you can't fuse past iron, let's just say this is the iron core, then gravity wins. And when gravity wins, it's coming towards that core so fast, you're going to get this explosion, and it's called a supernova. And when you get a supernova explosion, that's like when you get all other elements of the periodic table being created, right? And the star explodes, boom, goes into the galaxy, and then the result of that is going to be a neutron star, and that neutron star is just the remnant of the supernova, right? And the supernova, because gravity was so intense, gravity wins, gravity pushes everything that was fused, all the iron that was fused, so close together that it becomes this like really gigantic, super dense neutron star, and that's all that is left of the intermediate mass star. In a high mass star, it starts like with a nebula, and then you get nuclear fusion. And remember I said nuclear fusion can only occur till iron, and then fusion can't occur anymore. Gravity always wins. Gravity wins. You get this supernova explosion, but because you started with so much mass, that's the end of that becomes a black hole. And that black hole is because gravity won so bad that gravity is now this black hole which pushes all matter and all light, and nothing can escape through the black hole. And you guys should just check out the video on black holes. That's this guy called Kurgastek or something like that. He does this really cool thing on black holes. Kurgastek? I don't know. He does these like cool things, and you should watch it. Just type in KURG, and then it should come up. And you should watch it on black holes if you're interested. Anyways, fill in your notes about stars. I mean, the only other thing, I'm not going to do analyzing starlight. I'm just going to talk a little bit about the Doppler effect, and then I'm done. So the Doppler effect is just like what happens when you're standing on a road and a car passes by you, and they honk at you, like that kind of sound. Like it kind of sounds loud when it's coming towards you, and then it fades as it goes away. There's a really good video on the Doppler effect on YouTube, and I wish I was there to show it to you, but you guys can imagine, like, if there's a car and it's moving towards you. So here's this car that's moving towards you. It actually pushes sound waves, like, because kind of compressing it. So it's like pushing it like this, and then coming out, the sound waves are longer, right? So you can see that the sound waves are shorter here and longer here. And so that's called the Doppler effect. And that just makes sound travel kind of weird, because the car that's moving is pushing the waves in front of it, so they're close together, so it sounds like, And then when it moves away from you, right, the wavelength of the sound is longer, so then it goes, I don't know even how to describe it, guys. I'm just trying, but that's basically the Doppler effect, right? So if something is moving towards a person, you're gonna hear it when the car comes towards you. You can see the sound waves are compressed, they're smaller, so you're gonna hear like a higher pitch. And then you're gonna see as it goes away from you, like the car moves away from you, the sound, because the sound waves are less compressed, like they're more spread out, the sound, you hear it differently. That's called the Doppler effect. And you can see this in stars. So like if you're looking in the galaxy, right, and you're looking at a star, they actually track it, right? Like they track it and they call it redshift and blue shift. Now, if something is shifting blue, so basically they look at stars and they try to see like if they're redshift or blue shift. So imagine this is you and you're looking up at the stars. They notice that stars look like this. Stars are actually red shifting. So now when I say red shifting, remember red is a longer wavelength, blue is a shorter wavelength. They're noticing that all stars, right, have longer wavelengths here and shorter wavelengths here. They call this red shifting, and they think that all stars are moving away from the Earth and that the universe is expanding, right? Because no star is actually blue shifting. If a star was blue shifting, it would just mean the star is coming towards Earth, because blue shift means like blue has a higher frequency, and so that means we would see all this blue coming towards us. And then the red would be like it. So that's blue shift. So blue shift would mean like you compress the waves, and so they look blue because blue has shorter wavelengths, red has longer wavelengths. And so you would expect the stars coming towards the Earth to be blue shifted, but we're not seeing any of them. We're just seeing these longer red shifting wavelengths because all stars are moving away from the Earth. And anyways, that's all we're going to talk about today. And actually, that is the end of physics. And there's like practice questions you can do. And you guys can also just email me if you have any questions about physics, but we're done. And so, I mean, your physics unit exam is next week, and good luck